Okay, number 6 for Chapter 9 review. We're looking at terminal side of an angle in standard position. So we got this angle that's opening up. So standard position, it opens up and it lands in -4, 6. So the angle opens up and it lands as a point somewhere out here as going over -4 and up 6. All right, so maybe like up here. Okay, so redraw that a little bit. It doesn't really matter what the angle is here. Okay, so we have some angle here, right? And then we can basically create a triangle right here and use this reference angle. Okay, and again, I don't need to know that measurement, but I know this height, since this point is -4, 6, that means my x is -4 and my y is 6. So really it's the same problem as number 5. I just need to know what my radius is, right? So I can find that by taking the square root of my y squared minus my x squared, or plus my x squared, right? A squared plus b squared equals c squared, right? Don't worry about that negative, because when we square it, it's going to be positive 16. That's 36. So we get what? 42, 52? 52, and that would reduce down to what? 2 root 13. Yeah, 2 root 13. Okay, so I might want to keep it as root 52 when I'm simplifying. Okay, but this just asks what sine, cosine, and tangent are. So sine would just be y over r, so 6 over my radius. So sine of this angle, again, I don't need to know the angle, is y over r, which is root 52, which is 2 root 13. So 6 and 2 would cancel to 3 over root 13. Rationalize it, we get root 13 over 13. So look for that answer. So that's this one, sine, and this one, right? So now we eliminated 2 of them, right? So then find cosine, or maybe tangent might be easier, right? Tan of theta is y over r, or y over x. So y over x, so that'd be 6 over -4, which is reduces down to 3 over -2. So look for that one, -3 halves. -3 halves, so not that one. So look, we only had to do a little bit of work and we got it. And then cosine would just be reducing, it would be -2 root 13 over 13, because that is x over r. So -5 over 2 root 13, and simplify down to that. Okay, reference angle. So whenever we're in a reference angle, we always want to reference it back to 180 or pi, or reference it back to 0 or 360. So if we're in this quadrant, we reference it back to 180. If we're in the second quadrant, we reference it towards 180. If we're in the first, it is the reference angle is the angle. And then in the fourth, we reference it back to 360, right? So those are the 4 quadrants. Anytime it's radians, all we have to do is take the denominator. So it's dividing pi by 4, so that means it's pi 4s. So radians is a little easier. If it's in degrees, we have to see which quadrant it is, and then see how much to go to 180, or to come back to 180, or go to 360, or how much to go back to 0. And that's our reference angle in degrees. Okay, radian's pretty easy. It's just what are you dividing by? And it'd be pi divided by that. All right. So here we have a little problem. We have a door is 24 inches wide, and we can swing it open 140 degrees. So this is 24. Well, it's the same kind of thing right here. What is the reference angle down here? So if I've opened 140, that'd be in the second quadrant. So how much more do I have to go from here to 180, right? So that would just be 40, correct? So the reference angle should be 40 degrees. Now I can create my triangle right here. And this is a right triangle, right? So I have 40 degrees there. And then what I want to do is just find the distance in inches from the wall. So I want to find how far is this door opening to the wall. How far is that? So that's be my y value. Here's my x value, and here's my radius, right? So if I'm looking at this angle, y, I'm looking for y, and I'm given r, right? So which trig function is y over r? That would be sine. So sine of my angle, reference angle, which is 40, is equal to y over r, which is 24. So then solving this, I just solve for y, multiply both sides by 24, and so we get 24 sine of 40, and I can put that in my calculator, and I get 15.4. 15.4. Okay, so a couple things here. basically I can use my reference angle, and because I'm in the second quadrant, I would normally be in the second quadrant, right? Because I'm right here. So that means sine in both of these quadrants is positive, so sine of 40 is the exact same as sine of 140, okay? If I was in the third quadrant, it'd actually be negative, a negative answer for sine, because I'm below the x-axis, so my y values are negative, okay? But we just solve it that way. We could have just put 140 in here, 140 in here, and that would have been the same thing. Would have got the same answer, okay? All right, number 9 here, we want to find out, we're on the unit circle, so that means my radius equals 1. Okay, and then I have this point, 0.9, that's my x, and this is my y. We want to find what is sine of theta. Okay, so sine is y over r, so that would be 0.25 over 1, which is just 0.25, right? So that would be sine is 0.25. Okay, cosine is just x over r, so that would be x over 1, so that would just be 0.97. So 0.97. Tangent, it's a little bit harder. Tangent is x over y, so that would be, or y over x, sorry, y over x. So I actually have to divide that on my calculator, 0.9 or 0.25 divided by 0.97, and I get 0.2577. 0.26, so 0.26. Okay, and then we can just flip those, right? So cosecant would be 1 over 0.25, secant would be 1 over 0.97, and cotangent would be the 0.97 over 0.25. So 1, so that would just be 4, because 0.25 is just a quarter, right? So that would be 4. Then 1 divided by 0.97 is 1.03, 1.03, so that leaves probably 3.84, right, for cotangent. 0.97 divided by 0.25 is 0.88. 3.88. So 84, that looks like a little mess up there. Okay, 0.97. So there you go. All right, number 10 here. So again, if I have theta is 5 pi 6, I can convert that to degrees if I want to, right? Pi is just 180. So 180 divided by 6, just 18 divided by 6, and add a 0. So that would be 30 degrees, and 3 times 3 is 9, so we get 90 degrees. So we're at 90 degrees. So what is our quadrant, or what is our x and y at 90 degrees, right? So if I open up to 90 degrees, right? What is the quadrant there? That'd be 0, 1, right? Interesting. Okay, looks like I'm a little off there. Oh, that's not a 3, that's a 5. So probably you're confused by this. That's a 5. I was like, why am I 90? Because those quadrants right here, these things are not 90, right? So 5 times 3 is 15. That'd be 150. So I'm in the second quadrant, right? Reference angle is 30, right? My reference angle is 30. So if I look at a 30, 60, 90, right? So I'm over here. That's where I am. So this would be 1/2 on a 30 there, and this would be root 3 over 2, and this would be 1. So my y is root 3 over 2, or my x is root 3 over 2, but I'm to the left, so that's negative. And then my y is 1/2. So negative root 3 over 2 and 1/2, this one right there. Sorry about that. That it was a 5, not a 3. Sorry for confusing you. We'll end this video.